All right. Feeling pretty awake right now. All right. Maximum distance between a pair of values solved previously, medium. Okay, let's see if I can solve it again. You're given two non-increasing zero-index integer arrays, nums1 and nums2. Non-increasing. Okay, so generally decreasing, but could be ties. A pair of indices are valid if I is less than if a pair of indices where I is index I is from the first array and index j is from the second array is valid if I is equal to or before j and the value I is less than or equal to the value of j. Okay. The distance between the pairs are j minus I. Okay, distance is just the difference in the indices. Okay. Return the maximum distance of any pair. If there are no valid pairs, return 0. The maximum distance of any valid pair. An array is non-decreasing if, yeah, sure. So the maximum distance where you have something where a number in the first array is smaller than a number in the second array in that is at a later position, I guess. Looking at these, 55 just has 100, 30 doesn't really have anything. 5 has this 5, I guess. 4 has this 5, and 2 has this 5. So the maximum should be 2, I want to say, 5 to 5. Yeah, okay. So here 2 can go to this 10, so that's 1. This 2 can only go to this 10, which is 0. This 2 can't go anywhere, so it's just 1. And then this 30 can't go anywhere. This 29 can't go anywhere. This 19 can go to this 25, so that's 2. And this 5 can go to 25, so that's 1. Okay. I think this has something to do with what's the it's been so long. It's some type of array. It's or array or stack. Axiomatic? No. Monotonic stacks. This feels like a monotonic stack type problem where I have to just keep track of things. So I'm almost visualizing it as like if these values give you the height of like a mountain, like 30 high, then 29, then 19, like the mountain is kind of decreasing in height. And then this one is just a flat mountain. Like if it's kind of overlaid with each other, right? So it's like 30, 29, 19, 5, 25, 25, 25. So like if I imagine that's kind of like heights, like this height of the mountain needs to somehow have a blocking higher value. This also doesn't have anything, but then this one does. 19 to 25. So in theory, like your first value here matches with maybe if it's smaller than the last value here, then clearly that's the longest answer you can have, which is like the length of nums2 minus 0, which is the length of nums2. something like that. Maybe it's just length of num2 minus 1 if I think of the indices starting at 0. And if that doesn't work, right, like 30 is not smaller than 25, then there's two options, I guess. I can find something later on that's smaller than 25, or I can find something that is later on in the first array that is smaller than 25, so that pairs up, or earlier in the second array that's like, let's say this was 40, so that 30 can go to 40. So maybe it's not monotonic. It could be DP, dynamic programming. Never mind, I think this is too long for dynamic programming. Wonder if it could be binary search. Could it be binary search? I don't feel like it's binary search. I feel like it's linear, to be honest. Like monotonic is linear. This feels pretty linear. Both nums. Oh, I should have noticed this. Nums1 and nums2 are non-increasing. So that couldn't possibly be 40. So I mean, it could be, well, it could be 40 if it was something like 40, and then there's like a bunch of 50s over here. Okay, I need to leverage that. Yeah, it's almost certainly linear, especially with this. I almost want to say it could be linear even without this constraint, but should be pretty straightforward then. So 30, okay, yeah. So 30 here matches with, at some point, this thing increases to something past 30. Yeah. All right, like maybe over here it's 50, but there's some index where past that index, that's the latest index that it could be. Yeah, okay. Them are non-increasing. So they're basically decreasing with ties. Yeah, this is just 2 pointers. It's not even monotonic stacks. Like you just have a pointer in the first array, pointer in the second array. Outer loop moves the pointer in the first array, inner loop moves the pointer in the second array, moves the pointer in the second array. Let's see. Which direction does it move the pointer in the second array? So obviously the first pointer in the first array moves forward, like increases. Pointer in the second array moves forward as well, right? Moves forward, or doesn't move at all. So pointer here, and then like it can't move to here because 30 is not bigger than 20. Well, maybe it moves and stops here, so then it kind of knows that the previous one was where it should have counted. So maybe it moves to here, stops. Would that work? Because then 29, yeah, that probably works, right? And then 29 moves the first pointer to 29, still stays here, moves the first pointer to 19. This thing has to start at where the first pointer is, because it can't, I has to be less than or equal to j. So it starts here, moves forward until it stops. Yeah, this is probably 2 pointers. 2 pointers algorithm, technique, kind of method. 2 pointers type, two-pointer type problem. Okay, so answer is equal to, let's say, infinity, and then slowly decreases to 0. I wonder if there's a way to optimize that, because the answer, yeah, there might be a way to optimize that. I mean, it's still linear. Oh well, whatever. Start with infinity because it's gonna, because you're trying to, no, it should be 0, right? Because you're trying to maximize it, so it should be increasing if you can. Yeah, so start with 0. Okay. I'll use P1 and P2 for the 2 pointers. So for P, say N1 and N2 is the length of nums1 and the length of nums2. For the P1 for the first pointer in the array 1 for in range N1, right? Do I want to do a break? No, I think N2 should probably, P2 should probably use a while loop, I feel like. So P2 is going to start with 0. And then I think what should be happening is, so P2 moves out in front. I guess you probably move it as far as possible regardless. So like 30. What if it was something like 25 here? Maybe just don't move P2. You either start P2 as where P1 is, but then if P2 is already in front, like if this was 19 and it's already at 25, then 5 should hit 25, right? 5 being smaller than 19, it should also hit this. So it's like you should be continuing on where P2 is. If it's P2 is farther than P1. But then if P2 is behind P1, then do you just bump it? I think yeah, I think P2 should be floating, so I'm not going to use a for loop for P2. I'll just use a while loop. I'll just say while the value at P1. Oh, you know, so I want to do something to not have to check the range out of bounds ranging. I guess this is never going to go out of bounds, but P2 might. Anyways, well, nums at P1 is less than or equal to nums at P2. Then I can do P2 increase nums1 at P1 less than or equal to nums2 at P2. Then I should be able to increment P1. So that's like the 19, like P2 should just keep on going. Yeah, it should keep on going until it stops here, right? Or like it's going to stop, go out of bounds, but in theory it should stop here. Okay, and then at this point the condition is false. So that means that it went too far. Condition is false, went too far. So I think went too far actually means I should be able to subtract them directly rather than do like subtraction minus 1 or anything like that. So it's like answer is equal to maybe, in theory it should be like P2 minus P1, but that could be negative. So if it's negative, then I want to do max of this and 0. Oh, I guess it should be, actually I guess it should be answer p2 minus p1 or 0. I guess that should mean I should just be able to answer in p2 minus p1. Because if it's negative, then it doesn't work. Yeah, I think that's fine. And I'm going to go ahead and, like normally what you do here is to prevent it from going out of bounds, you just say like and like p2 less than n, or like this condition should be before the other condition, but I'm just going to do a hack here. A lovely hack. Nums append infinity. So it should always be such that, is it append infinity or append 0? Well, actually, I think it might be appending negative infinity. No, actually, so the values are 1 to 10 to the 5th, so I'll just append 0 because then there's no way that it'll go out of bounds. Nums2 will be smaller than the value in nums2, which should be smaller than the value in nums1 at that point, at the very end. Okay, I think that might be it. Might be it. I just got everything wrong. It looks like I'm off by 1, which is kind of, did I do my, I guess this should be p2 minus p1 minus 1, and think why. So it's going past it, right? So it's going, the indexing here is, so p1 is at 2, and the value is 19. It'll move until p2 is at index 5. 5 minus 2 is 3, but the distance should be just 2. Okay, yeah, I guess I just subtracted, I just got the difference wrong. Okay. What is going on? Dun, 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 dun. Okay. Cool, cool, cool. 2 pointers it is. Guess I can probably do a little consolidation here. This is just a hack to not go out of bounds when incrementing p2 pointer. Okay. Okay. So the summary here is going to be what? Yeah, this is kind of a basic kind of 2-pointer type problem. I mean, the fact that you have, the fact that the problem has 2 arrays where you're tracking kind of different locations in each is kind of a hint. Kind of. I mean, definitely thought about other things, but if this was non-increase, if this constraint wasn't there, I think it still could be linear. I have a sense that it could be linear, or at worst n log n. But given this is definitely kind of makes it a lot easier. Knowing that it's like basically decreasing. The fact that the arrays are kind of pseudo decreasing, right? Pseudo decreasing makes moving the pointers, or basically the second pointer, because the first pointer is just always just incrementing through the first array. Moving the second pointer always kind of reliable, like kind of no need to backtrack or worry about some other positioning. So try to find the farthest the second pointer can go, or one past. Basically, if the first pointer is at 30, then you want to go as far as you can to numbers that are bigger than 30. So assuming like 50, 40, 30, 20, 25, or let's say 55, 45, 35, 25, right? You want to push the second pointer to 35 or 25, probably 25 because you just want to stop when it doesn't work, right? Calculate the difference in position, update the answer to the maximum of that and current answer. I'm not really, I guess it's not really an easy problem per se. It's a little more complicated than an easy problem, but it is pretty close to easy. This is like medium easy rather than medium. It is lower middle class. Time complexity, this can be O of n, where n is the length. Well, what is n? N is the maximum. Is it O of m? Maybe O of n plus m, where m and n are the lengths of the two array. Maybe that's the most kind of appropriate description of this time complexity. You can also say O of like maximum of m and n. As you're iterating through both indices, both arrays with strictly increasing indices. So it's not O of n squared because the while loop here strictly is increasing p2. p2 never goes backwards. It'll go up to basically the end of the nums2 array. Yeah, so p1 obviously goes through all n1 values of the nums1 array. p2 basically can go through all n2 values of the nums2 array, but never backtracking. And space complexity can be O of 1, since no extra space is needed. Coolio.